Hello everyone, nice to meet you. I'm Victor, a math student from São Paulo, Brazil, and today I'm trying to talk a little bit diagnostic meta-analysis and how to do the statistics with STATA and how to do the meta regression in diagnostic meta-analysis. Okay, so all the guidelines of diagnostic meta-analysis, I'm using the Prisma 2080, I guess, and the STATA version, my STATA version, it's 418 version, I guess. So keep going and talk a little bit how to do create a table and how to do and import the table to STATA. Okay, the big motive and objective with this video is explaining the diagnostic meta-analysis and how to do. And I had many problems when I'm learning diagnostic meta-analysis, so I'll talk a little bit on many tips and how to import, how the codes, okay, and some field recommendations to introduce in this theme. Okay, so talk about this project. On the screen, I'm sharing my screen, and can I show with you some papers and studies when I'm including my diagnostic meta-analysis. Okay, like in different study designs, like transversal study, perspective, retrospective. Some papers is single arm, and few papers is control. Okay, all the papers I guess is single center, yes. And the gold standard to diagnosis is different in some papers. So being did in 2018, transient in BOTA 2015, transient elastography, and the others many papers with biopsy. So that's important thing. Talking this to show the very importance to stratify and not pull it all the results without the meta regression. So the correct is be separate the transient elastography and the biopsy and see the difference. Can you pull it? Yes, but the big deal when transient elastography and biopsy is different methods to diagnostic. So keep it separated. Okay, transient elastography and biopsy. So in your paper, check this and baseline studies to introduce the statistics with more robustness. Okay, keep going. About the outcomes, separate the outcomes: the major F1, major F2, major F3, major F4. Okay, and some different cutoffs and all the diagnostic meta-analysis to only construct the contingent table. What is this contingent table? Contingent table is this: true positive, true negative, and false negative to each study to include in the meta-analysis. Okay, so I'm sorry. Some papers in my study, I can construct the other classifications in the same study, like being the 2070 is in major F2 and major F3. So I'm construct the major 6.70, 29, 233, and 39, and 2 to true positive, true negative, and false negative. Okay, so in this other table, I can construct. I can construct the F1, F2, F3, and F4 separated to import with STATA. Okay, all this data you can and you could separate it the tables to each classification or each analysis to do. Okay, so each sheet it's a one analysis. Okay, bon, keep going. When you construct your table, the important things it's in column A, alter, column B, year, separated with alter. Okay, so the alter is only name and year only number. Okay, TP, TN, FP, and FN it's with numbers. Okay, and others, what is this? Two other columns without this first columns, all the other columns to do meta regression, and finally statistics. Okay, so 1 it's yes and 0 it's no. Okay, so this paper being the use C8C, so I'm put 1, and others like NAFL, other condition NAFL is not it's not available, so I'm put 0. Okay, and can you construct all the variables and conditions with you guess with can will change the results. Okay, so some example it's likely major 2020 papers published. So this one is 2018 and put 0. It's like others and older than 2020. Okay, and BOTA and others. So like Setnik and put 1. It's one example. Okay, I'm excluding this one. Okay, but how to import this data? My STATA version is 14, I guess, but the midas package is like older, so the same codes to introduce. Okay, I'm run my STATA right now, and the first thing when you start STATA, it's install midas. Okay, so as C install midas, and put enter and start the downloading. Okay. Yes. So the first and second, it's SSC install my labels. Okay, labels. Oh shit, my labels. When down to it's import your table. How to import my table? When you download your table, can you your archive download, and can you download it's Microsoft Excel mode? Okay. In R with meta DTA you use .csv, but when you use STATA.xlsx, okay, Microsoft Excel. So when you download, you return to STATA and file, import, Excel spreadsheet, browse, select your sheet, and when you're done this one, click here, import the first row's variable names, and the worksheet is F1, F2, F3, F4. So to introduce the statistics, I'm working on F1, so I'm start this one, okay, and put okay, yes, and check here all the variables. So NAFO Nash, code Nash, stay NAFO Nash, control, remove this one, okay, interrogation, so only control. So how to do the overall studies in output data? This code is midas, TP, FP, FN, and TN. How do I say virgula? Oh my fucking god. Comma, okay, comma. And comma, and rest. This one, all, and close this one, okay? And yes, but enter. And all the summary state and performance estimates are available to you. So can you select all and show? So the sensitivity combined is 0.82, specificity 0.822, and different confidence intervals, okay? In diagnostic ratio, positive likelihood ratio, negative likelihood ratio, okay? And the next is I'm show the PDF I'm use to introduce this one, diagnostic DTA, midas, 1 minute, I'm sorry, DTA STATA V version, okay. It's my my workbook to how to do. So you can use this code like midas TP FP FN TN comma modi C8 key, enter all and close this one and put enter, and others, okay, other graphs like guidance of fit, bivariate normality, influence analysis, and outlier detection, and return my workbook and do the bivariate box plot, midas TP FP FN TN comma and biv box, and put enter, and do the bivariate box plot, the logic sensibility and logic specificity, okay. And the others like combining input sensibility and specificity to this one code is midas TP FP FN TN common texts, and put here 0.60, and before put DSS space ID alter year space force, okay, and put enter, and combine the sensibility and specificity, okay. This one is force plot to introducing your paper and put in your paper, okay. This probably is the major objective and primary objective in our paper, okay. Keep going to use the summary hawk this midas TP FP FN TN comma is proc as proc, and put here buff and close and put enter, okay. So and create your summary hawk, okay, and close this one and keep going to introduce the regression and the funnel plots in the diagnostic meta-analysis. We use the Dix regression, okay, not the funnel or the Eagers plot, the Dix plot, okay. This regression in diagnostic meta-analysis we use Dix regression, okay. So the midas TP FN TN, I'm sorry, not this one. Return to paper. Introduce as style my labels and but bias, okay, but bias. And Dix funnel plot symmetric text available to you. And the statistics test for small state effects and publication bias, so like confidence standard error, the T interval, and confidence interval, okay, the bias intercept. So all this one is important to understand this graph, okay. So when you output your results with STATA, translate this code to your paper, okay, like supplemental material on other like limitations and publication by a section probably. And the Fagan plot, that's important plot and a very common plot. It's the Fagan. Okay, the Fagans to use the code is midas TP FP FNTN and Fagan and put 0.25. Okay, and put enter. And like the prior probability and likelihood root positive and likelihood root negative text to value predictive positive and value predictive negative. Okay, it's important. And the others, I'm sorry. Okay, here. The scatter matrix plots likely root positive and likely root negative bullet results. Okay, so this code is midas TP FP FNTN and L are mat. Okay, and put enter. When a bullet and this each number it's one steady. Okay, so it's 31, 32, 33, 34, 35, 36. Okay, and I'm showing to you on how to interpretation this graph. Okay, so left upper quadrant is exclusion confirmation, right upper quadrant and likelihood negative positive, major and thin confirmation only, and left lower quadrant and likelihood negative minor than exclusion only. Okay, and right lower quadrant likelihood ratio positive, major than, and likelihood negative major 0.1, no exclusion or confirmation. Okay, so that's important to how to understand the power. Okay, the power of this diagnostic methods. So, and to finally, okay. Oh yes, to finally probably modifying plot is the same, but understand with predictive value. Okay, so you can put this one probably in the supplementary material. Okay, to do this plot midas TP FP FNTN PD dam input into 0.25 space 0.75. Okay, and put enter. And okay, but the meta regression, how to do the meta regression? It's important thing to think in your diagnostic meta analysis. And how to do this? To do this, you can put midas TP FP FNTN, comma, space, rag, and open this one, and put these names, okay, by each variable when you use in these columns, okay? So, keep going. C8C, this one, C8B, AI8, NAFO Nash, this one, okay? NAFO Nash, code is daisies, biopsy, transient, elasto, and control, and close, and put enter. Okay, and the same covariate. In fact, when you use this one occurs, you can put this problem can resolve with this code. Okay, replace TP equal TP more 1, replace FP equal FP more 1, and replace FN equal FN more 1, and replace TN equal TN more 1. Okay, and put here and do the same code when you use here. Okay. Control C, Control V, and keep going. Yes, nice guys. So this is I'm sorry. The sensibility and specificity output, you can remove these ones and understand all the culminated and number of studies putting yes or no in this parameter in this category. Okay, so and create other force plot. I don't know if talk this one is a force plot, but linear variable meta regression supergroup analysis is the title about this paper, and to understand which occurs when you do in the categories each study. Okay, it's very important to do and show in your paper. Okay, this is variable meta regression supergroup analysis. I'm talking about this, and I don't know if forget some parts or some steps, but with others doubts you can put in comments. Okay, thank you very much, and keep going, man.